Hello students, so in this video we will be solving questions from the topic limits, continuity and differentiability, right? So the first question says, let this bracket denotes the greatest integer function and f of x is equals to limit n approaches to infinity 1 by n cube summation k equals to 1 to n greatest integer of k square divided by 3 power x, then 12 times this part. That means we need to first find f of x. See, the entire question would be easy if this bracket were not there, right? And directly we cannot remove the bracket just like that. ऐसे नहीं निकाल सकते. So what should be done, right? So we can say, see, x minus 1 is less than greatest integer of x, and that is less than or equal to x. Now this is the property of greatest integer function, right? Which you must be knowing. That means we can write 1 by 3 power x minus 1 less than greatest integer of 1 by 3 power x less than or equals to 1 by 3 power x. And next we can write 2 square divided by 3 power x minus 1 is less than greatest integer of 2 square divided by 3 power x, and that is less than or equal to 2 square divided by 3 power x, and so on, right? If I sum up all these things, then I'll be getting sigma k equals to 1 to n k square divided by 3 power x minus 1, right? Yeah, summation is there for this entire bracket, less than, we can write here also sigma k equals to 1 to n greatest integer of k square divided by 3 power x less than or equals to sigma k equals to 1 to n k square divided by 3 power x. Now we can definitely divide throughout the inequality with n cube, because n is a positive quantity, right? Now see, when n is approaching, the question says n is approaching to infinity. As n approaches to infinity, this term becomes very much greater than 1. That means this term will almost tend to infinity. That means this term will be very large, and in comparison to this this term 1 can be neglected. That means entirely, now this this sigma, now this so by sandwich theorem, we can definitely say that limit n approaches to infinity 1 by n cube sigma k equals to 1 to n greatest integer of k square divided by 3 power x will definitely approximate to limit n approaches to infinity 1 by n cube sigma k equals to 1 to n k square divided by 3 power x, as the limit is determined by the leading term, right? I hope you understood this, right? And that means now the entire question will be limit n approaches to infinity. Now we can write this as 1 by n, and we can take n square into the denominator here. We can write this as k by n whole square, and we can write this as 1 by 3 power x. Of course, with respect to this, x is a constant, we can write 1 by 3 power x outside. Then we have limit n approaches to infinity sigma k equals to 1 to n k by n whole square into 1 by n. Now this is definitely, we can use a definite integration here. Since it's an infinite expansion, infinite series, we can write this as integral. Now lower limit will be limit n approaches to infinity. Yeah, lower limit will be taking k as 1, right? So 1 by n. That means this will be 0. And for upper limit, we will write limit n approaches to infinity, and we will be taking this as the upper limit, n by n. Now this should be 1, right? And what does this mean? This is nothing but x, right? And this will be dx, right? As per the definite integration property. Now we will be writing this as 1 by 3 power x into, now integral x square is x cube divided by 3, and the limits are from 0 to 1. I hope you understood this. So we are getting 1 by 3 minus 0. So ultimately we got 1 by 3 into 3 power x, which is 1 by 3 power x plus 1, right? So then 12 times this value should be okay, so this should be required answer will be 12 times f of 1 plus f of 2 and so on till f of, and n approaches to infinity, right? J approaches to infinity, right? So this should be, what is f of 1? This is f of x, right? What is f of 1? F of 1 should be 1 by 3 square. F of 2 should be 1 by 3 power 2 plus 1, 3 cube, and so on. Now this is an infinite series in GP. So this should be 12 into a by 1 minus r, right? Sum of infinite terms in GP is a by 1 minus r when mod r is less than 1. Of course, here r is 1 by 3 and a is 1 by 3 square. R is less than 1. So we can use this formula. What is that? First term is 1 by 3 square, and the common ratio is 1 by 3. So we can write this as 12 by 9 by 2 divided by 3. So we get 12 by 3 into 2 is 6. 6 times 12 is 6 times 2 is 12, right? So I think the answer should be 2. I hope you understood this. So here the important application was of this sandwich theorem. Now this part and this part is same. That means this limit, yeah, so when you apply limit here by sandwich theorem, this should tend to this, right? This limit should be equal to the value of this limit, right? So that's what we are writing here by sandwich theorem. Yes, because this is neglected anyways. So yeah, now let us go to the next question. Next question, it says limit x approaches to 0 e power a minus 1 times x plus 2 cos bx plus c minus 2 into e power minus x and x cos x minus log of 1 plus x to the base c. So we will write down the expansions here. So firstly, let me write down the expansion of e power x first. That should be 1 plus x by 1 factorial plus x square by 2 factorial and so on. How do we remember this? Replace x with 0. Left hand side will be 1 and the right hand side is also 1, right? And also e power minus x is 1 minus x by 1 factorial. Replace x with minus x throughout since it's an identity. Here we get minus x whole square, which is x square divided by 2 factorial and so on. And next cos x is 1 minus x square by 2 factorial plus x power 4 by 4 factorial and so on, right? Minus x power 6 by 6. And log of 1 plus x is x minus x square by 2 plus x cube by 3 minus x power 4 by 4 and so on, right? How do we know whether this is correct or wrong? Replace again x with 0. We get log 1 is log 1 is 0 on the left hand side, and right hand side is replace x with 0. We get 0. Perfect. That means now the given question can be written as limit x approaches to 0. Instead of e power a minus 1 times x, we can write 1 plus a minus 1 times x divided by 1 factorial plus a minus 1 times x whole square divided by 2 factorial and so on, right? Plus again 2 times cos bx can be written as 1 minus bx whole square by 2 factorial and so on, plus c minus 2 times e power minus x can be written as 1 minus x plus x square by 2 factorial and so on, divided by now x into cos x. Cos x is again 1 minus x square by 2 factorial plus and so on, minus log of 1 plus x can be written as this x minus x square by 2 and so on, right? Now the thing is, x is approaching to 0. Where should we approximate? So let us first, so in this kind of questions, no, biggest problem is or biggest doubt is where should we which term should we return, or from which term can we neglect, right? That should be the question. That may be the question. For that, what will we do is we'll just see the denominator first. See, x into 1 is x and minus x. This gets cancelled, and ultimately we get minus x cube by 2 factorial plus x square by 2. I hope you are with me. That means x square by 2 minus x cube by 3 factorial and so on. Now the other terms will be power of x will be greater than 3. That means all these terms will be approaching to 0 since x is approaching to 0. In comparison to x square by 2, all these terms can be neglected. I hope you understood this. I'll repeat this. See, what we are doing is minus into minus is plus, x square by 2 we are writing it down, and all the other terms will be in higher powers of x. Then what should the next term be here? It should be x minus x square by 2 plus x cube by 3 and so on, right? We'll get minus x cube by 3, and here we have x into minus x square is minus x cube by 2 factorial and so on, right? Now all these terms which are higher powers of x in comparison to x square, all these terms can be neglected, right? Correct? Are you understanding? So these terms can be neglected. That means the numerator also we will be neglecting powers of x which are greater than 2. That means x cube and so on we will be neglecting. I hope you understood this, right? So numerator becomes 1 plus a minus 1 into x plus a minus 1 divided by 2 into x square. That's it from this part. And here we can write this as 2 into 1 is 2 minus 2, this 2 and this 2 gets cancelled. So we get b square x square. 2 into 2 divided by 2 is 1. And all the other terms can be neglected here. Again here also we can write this as plus c minus 2 into 1 is c minus 2, and c minus 2 into minus x should be minus x times c minus 2, and plus x square divided by 2 this term into c minus 2. I hope you are with me. Acha, the right hand side I think is given, that is equals to 2. See, that means the limit exists, right? Let me write the right hand side, that is 2. So we can write this as, now let us separate the terms. Limit x approaches to 0. Let us write down the constants first. 1 and then plus 2. 1 plus 2 is 3. 3 plus c minus 2. Acha, minus 2 plus 2 gets cancelled. Okay, we have 1 plus c. And do we have anything else? I think no. So we have 1 plus c as the constant. Now let us write down the x terms. So we have coefficient of x as a minus 1 here, and yeah, here if I take x common, I'll be getting minus c plus 2, that's it. Now let us write down the x square terms. We have here a minus 1 divided by 2, this term, and then minus b square, and then from here we can write it as plus c minus 2 divided by x square by 2, and now this limit is equals to 2. Now think up carefully. For limit to exist, degree of numerator should be equals to 2. Why? Achha, what if the degree of numerator is 1? Then what happens is, if the degree of numerator is 1, we will be getting something like this. For example, limit x approaches to 0, we may get x into some 2 divided by x square by 2. Now this 2 jumps to the numerator, we get 4 into limit x approaches to 0, we have x by x square, we can cancel 1x, we have limit x approaches to 0, 1 by x. Now this will approach to infinity, right? But the question says that the limit is 2. That means what? That means the constant term in the numerator, should be 0, and coefficient of x also should be 0, right? Correct? And coefficient of x square should be equals to 2. Is that clear? Yes, I hope that is clear, right? X, for example, if you write the x cube term and so on, what will happen is x cube divided by x square will be x, and limit x approaches to 0, x will be 0, right? Even if you write x cube and so on, the terms will be approximated to 0 because x is approaching to 0. I hope you are with me. That means since the constant term is 0, that means this term should be 0, which implies c plus 1 is 0. That means c is equals to minus 1. Perfect. Since the coefficient of x is 0, that means this term should be 0. That means a minus c, minus 1 plus 2 is plus 1. This should be 0. That means a is equals to c minus 1. And what is c? C is minus 1. Minus 1 minus 1 is minus 2. That means the value of a is minus 2. I hope you are with me. And the coefficient of x square should be 2. That means, see, now the question becomes limit x approaches to 0. This should be 0 and this should be 0, right? So we get x square into, and what is the value of a? A is minus 2. Minus 2 minus 1 is minus 3. So we get minus 3 by 2 here, minus b square, and c is minus 1. Minus 1 minus 2 is minus 3 by 2 divided by x square by 2. Now this is 2, right? I hope you understood this. Now this term, so the coefficient of x square here is this entire term. That means now we get 2 times minus 3 by 2 minus b square minus 3 by 2 should be equals to 2. This 2 jumps to the numerator, right? Now this gets cancelled. So ultimately we can write minus b square minus 3 by 2 minus 3 by 2 is minus 3. That should be equals to 1. That means ultimately we can write, did we make any mistake? 1 minute, let me just cross check. Yeah, here b square should be positive. I think we made a mistake. Let me once cross check. Yeah, 1 plus a minus 1 x, a minus 1 x. Okay, I think this should be square. So it should be a minus 1 whole square. So what will change is coefficient of x square will change. So this should be a minus 1 whole square. Okay. That means what will change here? A is minus 2 minus 1 is minus 3 whole square is 9 by 2. So this should be instead of minus 3, what should we write here? 9 by 2. So 9 by 2 minus 3 by 2 should be 6 by 2. So this term should be, so this should be 3 minus b square, right? So ultimately, yeah, I hope you are with me. Sorry for the inconvenience. So we get 3 minus b square equals to 1, and b square is equals to 3 minus 1, which is 2. Ultimately, what is he asking? He's asking us to find the value of a square plus b square plus c square. So a square plus b square plus c square should be, a square is 4, b square is 2, I think c square is 1. So 4 plus 2 is 6, 6 plus 1 is 7. I think 7 should be the answer. Yeah, we have 7 as one of the options. This should be the answer. Now let us move to the next question. So the next question says, f maps from all real numbers to 0 to infinity, positive real numbers, be a twice a differentiable function. So this may be a useful information. Let us see. Such that f of 3 is 18, f dash of 3 is 0, f double dash of 3 is 4, then limit x approaches to 1, log e, or log of f of 2 plus x by f of 3 whole power 18 by x minus 1 whole square, the base. Okay. So now Firstly, let us check is this an indeterminate form or not. Since logarithm is a continuous function in this interval, we can take this limit inside. Okay, we can take that limit inside, because limit x approaches to a, f of g of x can be written as f of limit x approaches to a g of x. Yeah, so it can be written if f is continuous at this particular limiting value. Right, since log is a continuous function, so we can take that limit inside. We can write this as log limit x approaches to 1. So what do we have? F of 2 plus x divided by f of 3 whole power 18 by x minus 1 whole square. Now let us see where, if x is approaching to 1, where does the base approach to? This is the exponent and this is the base. See, base will approach to f of 3 by f of 3. So this is approaching to 1. Where is the power approaching to? 18 by 0 is approaching to infinity. So this is of the form 1 power infinity, right? So this is 1 power infinity approaching form. So in this, what do we do in this type of questions? We write it as, let us say f of x power g of x, right? Limit x approaches to a, f of x power g of x, if it is approaching to 1, if it is in the form 1 power infinity, we can write this as e power limit x approaches to a, g of x into f of x minus 1. All of you might be aware of this, right? So with that understanding, now we'll write this term as, log e power limit x approaches to 1, 18 divided by x minus 1 whole square into f of 2 plus x by f of 3 minus 1. Of course, here we can further simplify this by writing it as minus f of 3 divided by f of 3. And if I rightly remember, f of 3 is 18, perfect. So we can cancel this and this. So ultimately we get log e power limit x approaches to 1, f of 2 plus x minus f of 3 divided by x minus 1 whole square. Now if I replace x with 1, numerator will approach to 0, denominator is also approaching to 0. So we can apply LH rule. What does that state? We can independently differentiate the numerator and denominator. We can write this as e power limit x approaches to 1. We can write this as f dash of 2 plus x into derivative of 2 is 0, derivative of x is 1 minus derivative of f of 3 is 0 because f of 3 is a constant, and here we get 2 times x minus 1 into 1. Again, now let us replace x with 1. We get f dash of 3 in the numerator and divided by, where it is f dash of 3 is also 0, perfect. So again numerator is approaching to 0 and denominator is also approaching to 0 as x is approaching to 1. So once again we can apply LH rule here. And now we will be getting this as f double dash of 2 plus x divided by 2 into derivative of x is 1. Now, so we will be getting this as e power, as x approaches to 1, we will get f double dash of 3 divided by 2. What is f double dash of 3? F double dash of 3 is 4, I think, right? So we can write here this as log e power 4 by 2, which is e square. So we get ultimately log e square to the base e, which is nothing but 2 log e to the base e, which is nothing but 2 into 1. So the answer should be 2. So do we have that as an option? Perfect. We have option 3 as 2. Now let us go to the next question. Next question, we have the value of limit x approaches to 0, log of secant dx into secant t square x and so on. Okay, so firstly quickly check whether this is an indeterminate form or not. So students, whenever you have questions in limits, first check should be which indeterminate form is it. Firstly, whether it is an indeterminate form or not. So as x approaches to 0, this bracket approaches to 0, ex approaches to 0, and secant 0 will approach to 1. So we get 1 into 1 and so on. And log 1 will approach to 0, numerator is approaching to 0, denominator, whatever denominator, cos x will approach to 0. Sorry, no, x is approaching to 0, cos x will approach to 1, I'm sorry. So we get e square minus e square, again denominator is also approaching to 0. So one thing we can think of is using standard limits or L'Hopital. So let me just write down first, we will see which form will be useful here. We can write the numerator as like this, because log AB is nothing but log A plus log B. I hope you are with me. So we can write this as secant e square x and so on plus log secant e power 10 into x, right? And denominator will do one thing. We'll take e square common. If I take e square common, I get here 1 minus e power 2x minus, what should we write here? Should we write 2 here? Is this correct? No, that's not correct. We should be writing minus 2 here, because once we multiply e square with 1, I'll get e square, and e square with this term, I should be getting e power 2 cos x, right? Now what will we do is we'll take minus common from the denominator, right? And 1 by e square will be sending outside, because e square is anyways a constant. We can write this as 1 by e square. Limit x approaches to 0, again log secant ex to the base e, and so on, divided by, let me take minus common, we get e power 2 times cos x minus 1 minus 1. So why am I writing this? Because we know one thing, that limit x approaches to 0, e power x minus 1 by x will be equals to 1, right? This is standard limit, right? We know this. As x is approaching to 0, this is 1, right? That means we will do one thing here. We will multiply and divide with 2 times cos x minus 1. Achha, most important thing is, as x is approaching to 0, this term should approach, this x should approach to 0. This term should approach to 0. Is it approaching to 0? Yes, it is approaching to 0. So we can apply the standard limit. So what do we get here? Now this will ultimately approach to 1. So we get, we have minus here. Let us keep the minus there only. We will be getting, and this 2 can be taken outside, we will be getting 1 by 2 e square into limit x approaches to 0 log secant ex to the base e plus log secant e square x to the base e, and so on, divided by, now what is remaining here is minus 1 into cos x minus 1. So minus 1 into cos x is minus cos x plus 1. So we ultimately get this. Now again the numerator, if you see, this is approaching to 1, right? As x is approaching to 0, secant x is approaching to 1. That means numerator is again approaching, log 1 is approaching to 0. That means numerator is approaching to 0. Denominator is also approaching to 0, because 1 minus 1 is 0. Yeah. Again, now we can apply LH rule here. So we get 1 by 2 e square. Differentiate the numerator and denominator. So if I differentiate this term, I get 1 by secant ex into derivative of secant ex is secant ex into tan ex into derivative of ex is e. Achha. So ultimately what is remaining is e tan ex. Achha, if you have understood this, let me directly write now. So if I differentiate this term, I get e tan ex. Achha, if I differentiate this, what should I be getting? I should be getting e square tan e square x. Achha, if you are students, if you are doubtful, once just differentiate this and check, you will be getting this. The last term should be e power 10 into tan e power 10 x. I hope you are with me. Yeah. Divided by here, derivative of 1 is 0 and derivative of minus cos x is plus sin x. Achha. Now we have sin x here, right? Again we can multiply and divide with x, right? Now this term, as x is approaching to 0, this term will approach to 1. So ultimately we are left with 1 by 2 e square, limit x is approaching to 0. We have e tan ex plus e square tan e square x and so on, plus e power 10 tan e power 10 x divided by x, right? Now can we split it? Yes, we can split the sum. So we can write this as e tan ex divided by x plus limit x approaches to 0. We can write this as e square tan e square x by x and so on, right? Now what to do with this? See, coefficient of x is e here, so we'll do one thing, we will multiply and divide with e. Now we can write this as 1 by 2 e square into e is e square. We can take it outside, limit x approaches to 0, we have tan ex divided by ex. Plus here if I take e square outside, I get e square into, achha, I should multiply and divide with e square here. So e square into e square is e power 4, I'm sorry. Now this will be limit x approaches to 0 tan e power e square x divided by e square x and so on. Now this is anyways 1, this should also be 1. That means what are we finally getting? We are getting 1 by 2 e square into e square plus e power 4. Achha, next term should be I think e cube will be getting here, right? E cube into e cube. So it should be e power 6 plus e power 8. So what should the last term be? It should be e power 10 into e power 10. It should be e power 20. I hope you are with me. Now we can take e square common from the numerator and we can cancel this. So we will be left with 1 plus e square plus e cube, and this should be e power 18. Now sum of n terms in GP should be a into r power n minus 1 by r minus 1. This n is number of terms if mod r is greater than 1. So we can write this as 1 by 2 into a is 1, r is e. Achha, what about r? Should it be, okay, I'm taking e square common, right? it should be 1 plus e square plus, I think we just, did we make any mistake? Here I'm getting e square, here it should be e square into e square should be e power 4. The next term, yeah, it should be e power 6, right? Yeah, it's e power 6, e power 8, correct, no? So if I, okay, so this should be, this is the mistake, so this should be e power 4, I'm sorry. Because if I take e square common from here, I will be left with e power 4 and then e power 6, and if I take e power 18 will be left. That means the common ratio is e square, right? So I will be writing it as e square whole power. Number of terms are starting with e power 0 and ending with e power 18. That means e power 0, e square until e power 18. So that means there are 9 terms, right? Totally there are 9 terms or 10 terms? I think there are 10 terms, I'm sorry. So here we'll write it as e power 10, e power e square whole power 10 minus 1 by e square minus 1. So what are we left with? 1 by 2 into e power 20 minus 1 by e square minus 1. So this should be the answer if I am right. So do we have that? What do we have? E power 20 minus 1 by 2 times e square minus 1. E power 20 minus 1 by 2 times e square minus 1. So option 1 should be correct. Right? That's it. So thank you for watching this video, dear students. Meet you with the next one.